Okay? Another one is if we look at butane. If we look at butane, you can see it a lot better. So let's look at butane, which CH3, CH2, CH2, CH3. And what we're going to look down is we're going to look down carbons 2 and 3. That's the bond that we're going to look down. Okay, so this carbon is going to be the carbon in front. All right, so you always have three things. 1, 2, 3. Okay, I have a carbon because that carbon is attached to the other carbon. That's the carbon in the back. So if you want to always start a Newman projection like this, where you have your three bonds and your circle. So carbon 2 is in front, and attached to carbon 2, obviously, is this big group. That's the group in the back. But this carbon has two hydrogens attached to it. So I don't know, let's just put a hydrogen here. It doesn't matter where you put them. And then the third thing it's attached to is this whole CH3 group. Okay, so that's a carbon with three hydrogens. I'm going to first draw it in a an eclipsed conformation. Then the carbon in the back, carbon 3, has two hydrogens and another CH3 group. So let's draw them eclipsed. It's hard to do. All right, you kind of have to practice it a little bit. But again, sometimes it's hard to see. Okay, so this is an eclipse conformation. Okay, notice though, in this case, you have two gigantic groups eclipsing each other. In the previous example, we just saw two little hydrogens. Now we have two CH3 groups, so it's a carbon with three other hydrogens. Imagine how much steric interaction is in this molecule. So this is a very high energy conformation. So which means very high energy. Right, I'm sorry. So all because of these two large groups, you have a very high interaction, which makes this molecule very high in energy. Okay. Well, now if we rotate around the carbon-carbon bond 60 degrees, okay, so this methyl group comes over here, the hydrogen comes over here, and this hydrogen goes over there. The back stays the same. All right. I now have a staggered conformation. So I've alleviated a lot of that steric strain between those two methyl groups. But the two methyl groups are still close to each other. All right? Even though I have a staggered conformation, it's still not ideal because I still have an interaction between these two groups. This particular interaction is called a Gautsche interaction. Okay? Gautsche interaction. All right? Steric interactions are much worse. These are worse. These things are right on top of each other. They're hitting each other. They're not very happy. Gaussian interaction, you're at least in a staggered conformation, but they're still interacting with each other. That's still not ideal. Okay? So let's keep rotating this around and see what happens. Rotate around another 60 degrees. I now have a hydrogen on top, a hydrogen here, the CH3 to the right. And then in the back, remember the back, I'm not moving anything. Okay. You'll notice, though, that this is now an eclipsed conformation. Okay. You still have a steric interaction right here. Okay. But it's not nearly as bad as the steric interaction as above, because rather than having two methyl groups, you've got a methyl group and a hydrogen. Still not ideal. You also have another one right here. So this technically, you've got, two of them. Let's rotate it another 60 degrees. Right? Now, what you'll notice is these two methyl groups are as far away from each other as possible, which I'm hoping you would realize that is very ideal. The two large groups, your two methyl groups, are as far away from each other as possible. This is called the anti-conformation, because your two groups are anti to each other. Conformation, it's an A. Okay, 1, you're staggered. Okay, 2, no sterics. 3, no Gauche. All right, so this is a very stable conformation. So this is the conformation that this molecule prefers to be in. And again, if you were to turn it sideways and to look at it, it would look like this. CH3, and then you'd have your CH2. I'm not drawing in the hydrogens in 3 dimensions because we've already done that. CH2 and a CH3. Okay? So the Newman projections kind of help you to see how many Gauche interactions you have, how many steric interactions you have, and how to alleviate all of those issues.